Section 7.4 is on bootstrapping, using technology for estimates. We will specifically be looking at the actual results of the bootstrapping. The sampling requirement is that the process requires a simple random sample, but bootstrap methods do not correct for poor sampling methods. Meaning that if we do not have a simple random sample, the bootstrapping isn't going to really help regardless anyway. It only helps if we already have the simple random sample. The fact that this is trying to correct is with respect to that normal distribution if we do or do not have one of those, or the required sample size, for example. It's a nonparametric test, so it's distribution-free method, as it does not require the sample to be collected from a normal distribution, or any distribution for that matter. We'll be looking more on nonparametric tests on a different section later in the course. The method can be used if the following requirements are broken. So the at least 5 successes and at least 5 failures for the sample, for the population proportion confidence interval. For the population being normal or the sample size is greater than 30, for the population mean confidence interval, and the confidence interval for the standard deviation of variance when the population is supposed to be normal. The Bootstrap Samples is given a random sample of size n. A Bootstrap sample is another random sample of n values obtained with replacement from the original sample. Bootstrap is used because the data pull themselves up by their own bootstraps to generate new data sets. It seems like it should be impossible, but it works in this case, so hence the name. Examples here will generate 20 bootstrap samples. In real life, you would typically use at least 1,000 bootstrap samples. Professional statisticians use 10,000 or more. As a side note, of course. An example of what this bootstrap sample is referring to. When one of the authors collected annual incomes of current statistics students, he obtained these results in thousands of dollars, 0, 2, 3, and 7. And we could form ourselves a bootstrap sample by taking 7, 2 values of 2, and 1 value of 3. So a sample of 7, 2, 2, 3 is one bootstrap sample obtained from the original sample. Other bootstrap samples may be different, but this is just one variation thereof. So one, we'll call it type. The procedure for a confidence interval estimate of a parameter, we would first be given a simple random sample of size n, obtain many. Our examples use 20, but such as 1,000 or more bootstrap samples of the same size n. For the parameter to be estimated, we want to find the corresponding statistic, so a sample proportion, sample mean, or sample variance. For each of the bootstrap samples, we would sort the list of sample statistics from low to high, and then create the confidence interval by finding corresponding percentile values. For example, for a 90% confidence interval estimate, you would use the 5th percentile as the lower bound and the upper bound as the 95th percentile, with the parameter between the two. So for example, in a survey, 4 randomly selected subjects were asked if they have brown eyes. Here are the results, 0, 0, 1, 0, 0 being no, 1 being yes. We would use the bootstrap resampling procedure to construct a 90% confidence interval estimate of the population proportion P, the proportion of people with brown eyes in the population. We obtain those 20 samples. We find our population, our sample proportion P hat by taking the proportion in each of these with brown eyes, and then we sort them from lowest to highest and find the 5th percentile to be 0 and the 95th percentile to be 0.75. So the confidence interval is between 0 and 0.75. So 0.00 is less than p, less than 0.75. Written out in words is the 90% confidence interval estimate of the population proportion is 0.00 less than p less than 0.75. But something like this, though, is probably not really too helpful. Why is that? Well, there's only 4 in our original sample. So there's only 4 in the original sample. I know it said this is a random sample, so that was fine. But there's only 4 here. And as such, because of that, such a small sample, it's not going to be really too helpful per se, unfortunately. And as you can tell, this is a very big confidence interval for 90%. Between 0 and 0.75, that's almost the entire thing to begin with. For another example, this time now of the population mean, when one of the authors collected a simple random sample of annual incomes in his statistics students, he obtained these results in thousands of dollars, 0, 2, 3, and 7. Using the Bootstrap resampling procedure to construct a 90% confidence interval estimate of the mean annual income of the population of all the author's statistics students. Again, there's only 4 here, so we will need to take what we are doing, unfortunately, with a grain of salt, since, as you can tell, the confidence interval is kind of big. But we take each of those 20 Bootstrap samples, find our sample mean for each of those, and then order it from least to greatest. 5th percentile is 1.75, 95th percentile is 4.875. So the confidence interval is 1.75 in thousands of dollars, less than mu, less than 4.875. Again, in thousands of dollars. Written out in words, this would be the 90% confidence interval estimate 90% confidence interval estimate of the population mean is 1.75 less than mu less than 4.875, where the values are in thousands of dollars. Based upon this particular example. And then for one last example here, using these sample incomes in thousands of dollars from example 3, 0, 2, 3, and 7, use the Bootstrap resampling procedure to construct a 90% confidence interval estimate of the population standard deviation sigma, the standard deviation of the annual incomes of the population of the author's statistic students. We obtain these values down here from this. Again, there's only 4 inside this original sample, so the results will be unfortunately questionable. The 5th percentile, when we try to construct that for this, is going to be 1.26. And the 95th percentile, 95th percentile is going to be 3.44. So the actual confidence interval is 1.26 less than sigma less than 3.44. So in interpretation wise, this would be the 90% confidence interval estimate confidence interval estimate of the population standard deviation. Standard deviation is 1.26 less than the population standard deviation less than 3.44 in thousands of dollars. Thank you.